Hey, let's talk about inheritance. So we always talk about Java being an object-oriented language. And the reason we say that is because everything in Java, aside from primitive types, is an object. Meaning at the very top of the heap, there is a Java file called object.java that defines what objects are and what they can do, which isn't really a lot. But what this allows us to do is to write all these other programs that can handle working with objects. And if we say, well, everything's an object, meaning kind of like tree of life, if everything that we talk about, whether it's strings or persons or animals, if they're all objects, and we say we know how to print objects or we know how to sort objects, then we inherently know how to print persons and sort strings. So let's see how this really affects us. We're going to write a program. It's pretty broad. We're going to talk about vehicles. And we might have a few properties that we say are kind of universal to vehicles. So one of those properties might be the direction it's pointing. Now, all vehicles have a front to them, let's say. Another property might be a speed. Another property or have a method. Maybe we could say they can all go. They can all stop. Alright? But vehicle's pretty broad. I mean, a vehicle could be a whole bunch of different things. It could be a motorcycle, it could be a car, it could be a boat, it could be a helicopter, it could be an airplane, it could be a blimp, it could be a skateboard. So, rather than make all these disparate classes, skateboard, boat, car, and define these same properties over and over again, we say, let's take the thing that they all have in common. All vehicles have a speed, they all have maybe a top speed, they all have a direction, etc., and start breaking down from here. Now, since vehicles are objects, all the things below here are also objects, but now we've gotten to define a few things for all of them in addition to the stuff they inherit from object. So let's say one category I want to go down to is cars, and maybe another category we want to go down to is boats. Alright, so something fundamentally different between boats and cars is the number of wheels. So maybe for cars we have a variable called number of wheels, which is something that a boat wouldn't have. A feature or a method that a boat might do that a car might not do is a drop and anchor. You know, that would be a method that doesn't make sense for cars. And since it doesn't make sense for cars, we wouldn't put that up here with vehicle either because it doesn't make sense for all vehicles. But now we have a method or an object boat that can drop anchor, go, stop, has a direction, has a speed. We have cars that have a direction, speed, and go and stop, and they have a number of wheels. So by inheriting properties, we inherently make all the classes further down easier to describe, easier to work with. Now, we can keep going with this. Under cars, we could get into things like maybe you have a category for SUVs, and maybe you have a category for trucks. Maybe you have a category for buses. So we could certainly break this down more and more and more and more. But the reason we do it, the main reason we do it, is to have the flexibility to talk about vehicles knowing it could be any one of these things. So for instance, if I were to say, can you drive a car, I would expect you could drive everything underneath here. So maybe we want to make some distinctions. Like maybe buses and trucks would be in a different category. Or maybe boats and cars would be in the same category of something that's drivable, but like a personal vehicle versus trucks and buses, which might be more commercial. But how we break down this inheritance tree helps us to kind of group similar properties and similar functionalities, which is going to be really valuable when we start talking about polymorphism, which is the next video. So check it out. Bye.